Hi, I'm Francisca Rojas. I'm the Research Director with the Transparency Policy Project, and I'm here with Jeff Warren of the Public Lab for Open Technology and Science. And we're just here to talk a little bit more about his project. And it relates to our work here at the Transparency Policy Project, because we're interested in how citizens can become the disclosers and aggregators of information that can help to mitigate public risk. And in the case of the Public Lab, they've been doing work along these lines, particularly around environmental monitoring. So the first question, Jeff, is why is it important to establish an independent source of data to monitor the environment, and why is it important that this information be generated by the grassroots, by the citizens themselves?
Well, I guess the BP oil spill is a good example of how the information that was collected and distributed around a specific environmental crisis was very opaque. It was kind of behind closed doors. The data releases that did occur were in formats that were relatively illegible to the people who were perhaps most concerned with the conditions that they dealt with. But I also think that besides just offering a different perspective on the same situation, which could be very different, one of the major benefits is that local residents of an area are in most cases much better equipped to collect good data or convincing or compelling data about a situation. Not only because they have an interest in doing a good job, but also because they often know the conditions, the local conditions that result in good data collection. So I think a good example is the 1980s kind of Cumbrian sheep farm radiation exposure situation in the UK, where local farmers, they knew where contamination was going to gather, or where it would persist, or where if there was runoff, where it would collect. And so they ended up being much better equipped to identify places to sample from than the scientists are doing it. Or in the case of SafeCast, the government data is one recording per city at an altitude of 10 meters, as opposed to many per city at an altitude of 1 meter, which is a better higher resolution and better reading of the actual data. So I think that local residents have often a much better sense of the context to create a successful data collection regime.
And they have the incentive as well, since what they're monitoring affects their livelihood and their health.
Absolutely.
As well. So what's a really interesting aspect of the work you do is that not only is the data that's collected by people open source, but so are the tools. And the tools that people use, they actually can build themselves. And your organization does a lot of capacity building in helping to kind of generate that whole dynamic. Can you talk a little bit about why that's the approach that you all take?
Well, I think the first part is really just cost. I mean, many professional tools that are the counterparts to the tools we use in our community cost hundreds or thousands of times more. Are you going to use a balloon or a kite to send up a camera and take pictures, or are you going to build and launch a satellite by yourself? They're just a matter of difference in that respect. But I think that our stance on what we call methodological transparency is that if people are involved in producing the data themselves and understanding how it is produced or collected, then they are in a better position to understand and apply and leverage that information. And they can actually, in the same sense that local residents are in a very good position to know when to sample or where to sample, they may also be better equipped to design tools that will result in better collection or better data sets. And so sometimes we've had tools that were kind of brainstormed or invented in one place, but once they were used in the field by local community residents, they were modified, they were adapted to local conditions, and they result in better data collection. So there's many different benefits, and of course, it has to be balanced with the desire to provide simple tools. Can you think of something simpler than just going to the store and buying a radiation detector and just using it and reading it? Well, that would be nice, and in some cases I think our tools will progress to the point where it is that simple. But I do think that you know, constantly refigurable tools and ones that people really understand have a lot of additional benefits.
Mm-hmm. And that, do you see that contributing also to kind of the sustainability of these volunteer-led efforts to monitor the environment?
Yeah, I mean, even at the simple level that if a company decided to produce a tool, they might optimize it for the market, not optimize it for the science, right? They might produce it at a certain rate, at a certain price point, which might not match up with a local community's needs, and then, you know, they might decide to stop producing it. There have been many examples of useful pieces of technology which the companies, you know, the creating companies simply decided to stop offering, and then there's a very lively, you know, aftermarket kind of exchange of them. So I think that having control over the production of the tools themselves is also, you know, has a lot of benefits.
And then I guess another question I think is about, you know, what do you see the outcomes of these data gathering efforts to be? What are you trying to achieve? How do you, how do you see this data being used by whom and to affect what?
Sure. I mean, it's a very big question, and it's the one that I think we've made the least progress on, but hopefully that means we've just made a lot of progress on the other parts. But I think it ranges from you know, the large-scale outcomes that we really hope for that you know, include policy changes, regulatory compliance, you know, determining the outcome of legal struggles, simply providing compelling evidence, you know, in the sense of compelling science to establish baselines and you know, provide a good description of what is actually happening, all the way down to the local level where, you know, we'd like people to be able to take measurements and then adapt to the presence or absence of contaminants, to remediate. In some cases, it's possible to plant certain types of vegetation that will absorb you know, certain contaminants. So that's a direct intervention. There's an example of a group of nonprofits in Alabama who have been building a reef artificially in order to cultivate certain species that will remediate the contamination in that area and help the ecology recover. So there's many different scales at which this could happen, and for better or worse, we're tackling a lot of them all at once. Definitely we've developed tools such as the thermal flashlight where people can detect a heat leak in their home and then immediately insulate that spot better, you know, and that's a very small life cycle or data loop. But you know, we're also looking to partner with you know, larger organizations that have legal traction or regulatory traction. We've had some success in that. I think that's an area we really need to spend a lot of time on as a community.
Well, thank you, Jeff, for sharing your knowledge with us, and you can find the Public Lab at publiclaboratory.org online, and there you can find all of the documentation of how to actually build the tools, how to generate your own data as well, and we look forward to keeping track of your progress. Thank you.